All right, these notes are dilations part one. And so this is the first topic we're going to cover in geometry. So a dilation is a transformation whose pre-image and image are considered similar. So we have this diagram here, and in class I kind of compared this to when you use the flashlight and do finger puppets against a wall or something like that. So the center of dilation, that's kind of like our flashlight. The pre-image you can think of as maybe your hand, and then this is the shadow that it creates. So the pre-image is the figure that we start with, and the image is the transformed figure. It's the dilated figure. And so dilation, you may think of, I don't know, when you hear dilate, you may think of your eyes being dilated. That means your pupils are getting bigger. So in math, it could mean when something is getting bigger or smaller. And so in this diagram here, you can see we use a scale factor of 2. So our pre-image got bigger by a scale factor of 2 to create our image. And so these triangles in geometry, we call these similar. And it kind of means really what it means in English. But in geometry, it means that the angles are congruent and the corresponding sides are proportional. So these were growing by a scale factor of 2, all the sides. So that's what I mean by proportional. And so when our scale factor is greater than 1, like this example, we call that an enlargement. If our scale factor is less than 1, we call that a reduction. If the scale factor were exactly 1, well, nothing would happen at all. It would stay the exact same size. Okay, so we're going to look at an example down here. So everything in these notes, we're dilating about the origin. So in other words, this point right here, 0, 0, that's our center of dilation. That's kind of the flashlight you can think of. So let's start by plotting triangle ABC. So A is at 2, 0. 2, 0, that's right here. I'm going to label everything. B is at 2, 4. 2, 4. All right, and then C is at -1, +5. Okay, and it's important you know how to plot points, or else this really won't go too well. So I'm going to connect my points, and this is our pre-image. This is the figure that we're starting with. Okay, and so just to stay organized, I'm going to go ahead and rewrite each of my 3 coordinates down here, just copying them. So I have A is 2, 0, B is 2, 4, and C is -1, 5. So we're dilating this about the origin by a scale factor of 2. Since the scale factor is greater than 1, we know that this thing is going to get bigger. We call that an enlargement. And whenever we're dilating about the origin like this, these problems are super easy. We just take the coordinates from our pre-image and multiply by the scale factor. So everything is going to get multiplied by 2. And that's going to give us the points for the image. And you can see I'm labeling these with this apostrophe, and in geometry that's called prime. So this is A prime, B prime, and C prime. We put those primes on whenever an image or a figure or a point has been transformed. So if I were to transform this triangle again, I would have to use double primes, etc. So anyway, we're going to multiply A by 2. So let's see, 2 times 2 is 4. 0 times 2 is 0. Okay, and for B prime, 2 times 2 is 4. 4 times 2 is 8. For C prime, -1 times 2 is -2. and 5 times 2 is 10. So that's how we get the coordinates for our image. So I'm going to go ahead and plot these, and then we can take a look at what we have. So let's see, A prime is 4, 0. I'm going to label that A prime. B prime is 4, 8. And C prime is -2, +10. Okay, and then I'll just connect my points. And then we can take a look at what we have here. And so you should be able to check each of these problems for reasonableness. If this is our flashlight and we're projecting this blue triangle, our pre-image, it makes sense that the pink image looks the way it does, right? If you think about it like a flashlight and a finger puppet shadow. Another way we can check this is we could draw straight lines through our corresponding points. So if you were to draw straight lines through your A's, and then through your B's, and then through your C's, you know, C and C prime, they're all going to intersect at the center of dilation. And that's true every single time. So that's a good way we can check this. But really, you should just be able to look at it and say, yeah, this looks reasonable. This looks like a dilation. So let's go to problem 2. Okay, this one's already plotted for us. It's a quadrilateral, meaning it's a 4-sided figure. So I'm going to go ahead and find each of these coordinates and list it out right here. So let's see, A is at 4, 8. B is at 8, -4. C, that's 0, -6. And D, that's -4, -2. Okay, so we have all of our coordinates. Again, we're dilating about the origin. So this is an easy problem. All we have to do is take our coordinates from our pre-image, you know, our original figure. We're going to multiply by this scale factor of 1/2. Since 1/2 is less than 1, we know this thing is getting smaller. We know it's going to be a reduction. I'm going to go ahead and multiply everything by 1/2. And some students get a little nervous here because we're dealing with fractions, but keep in mind, if we're multiplying by 1/2, I mean, multiplying by 1/2, that's the same thing as dividing by 2. Or, you know, multiplying by 1/3, that's the same thing as dividing by 3. Multiplying by 1/4, that's the same thing as dividing by 4. So that's what you want to do to make this easier on yourself. Okay, so we're going to find A prime, B prime, C prime, and D prime. Okay, we're going to multiply these by 1/2, but again, that's the same thing as dividing by 2. So 4 divided by 2 is 2. 8 divided by 2 is 4. I'm going to go through all of these. For B prime, well, 8 divided by 2 is 4. -4 divided by 2 is -2. For C prime, 0 divided by 2 is 0. -6 divided by 2 is -3. And then for D prime, -4 divided by 2 is -2. -2 divided by 2 is -1. So let's go ahead and plot these points for our image. So there's A prime. And right away you can see how if I were to draw a straight line through A prime, in my center of dilation, it forms a nice straight line, and that's what we're always looking for. Okay, so for B prime, let's see, that's 4, -2. Same thing, straight line through those, that works. For C, we got 0, -3. And then D prime is -2, -1. And then we can connect our points. And you can see how this looks like it makes sense. The flashlight is right here. You can think maybe it's like coming at us. It's one way to think of it. But the figures are similar. They have congruent angles and the sides are proportional. Okay, let's go to the back side. Got a couple more examples here. So example 3, we have another triangle ABC. We are dilating at about the origin. And it's a scale factor of 3. So it's greater than 1. We know it's going to be an enlargement. I'm going to start by plotting my points for triangle ABC. So A is at 3, 0. B is at 2, 2. And C is at -1, 2. It's kind of a small triangle to start with. We are going to dilate by a scale factor of 3 about the origin. So the origin is kind of like our flashlight. We're going to be projecting it so you can kind of figure out where our image is going to be. We're projecting it this way. So our image is going to be somewhere up in this region in quadrant 1, a little bit in quadrant 2 as well. So I'm going to list out my points again. You don't have to do this. I'm sure some of you at this point can just do it in your head, and that's fine. These are pretty easy problems. But just for organizational purposes, I'm going to go ahead and list out my points again. So I have A at 3, 0, B at 2, 2, C at -1, 2. And we are going to multiply by that scale factor of 3. So that's how we're going to get A prime, B prime, and C prime. Okay, so let's start with A prime. Well, 3 times 3 is 9. 0 times 3 is 0. For B prime, 2 times 3 is 6. And 2 times 3 is 6. Then for C prime, -1 times 3 is -3, and 2 times 3 is 6. Okay, so then we'll go ahead and plot these points to get our image. So A is at 9, 0. B is at 6. Let's see, 6. And then C is at -3, 6. Okay, so I'm going to go ahead and connect these points. And I probably should use a straight edge if I want it to be perfect, but this will do. And so looking at this, you can see how this would be correct. It looks reasonable if you were to do the straight line test. We got straight lines through A, straight lines through B, straight lines through C. So this looks good. Okay, we're gonna go to example 4. Last example here. We got another quadrilateral, A, B, C, D. So I'm going to go ahead and find those coordinates for A, B, C, D. Looks like A is at -8, 2. B is at -2, -2. C, that's 3, -2. And D, that's -4 and 10. Okay, and we're dilating by a scale factor of 1/2. So we know this is going to get smaller. It's a reduction. So we're going to multiply all these by 1/2. And it's this simple because we're dilating about the origin. Right here. So it's kind of like our flashlight. All right, and remember, multiplying by 1/2, that's the same thing as dividing by 2. So for all of these, we're going to have to divide by 2. Even this odd number right here, we're going to deal with a decimal, and that's okay. So let's see, -8 divided by 2 is -4. 2 divided by 2 is 1. -2 divided by 2 is -1. -1. 3 divided by 2. We're going to leave that as a decimal. That is 1.5, and I'll show you how to plot that. Negative 2 divided by 2 is negative 1. And here, when we divide these by 2, we'll get negative 2 and positive 5. Okay, so let's go ahead and plot these. For A prime, we have negative 4, positive 1. There's A prime. B is negative 1, negative 1. B prime. C, it's going to be 1.5 and then negative 1. So I'm going to go over a full block and then half the next one. That's 1.5. And then I'll go down the 1. So there's C. So again, I went over a full block, half of the next one, and then down a full block. And then D is at negative 2, positive 5. So it'll be right there. And then we can connect these points. Oops. I should have done better on that one, but oh well. As long as our points are good, that's what really matters. Okay. So I messed up a little bit with that line, but close enough. You can see all of our angles are still congruent. Our shapes are proportional. These are similar figures. If you do the straight line test, you'll find that they all go through the center of dilation. So this is good.